Hello everyone, just finished work. Today actually on my way home I was like, you know what, I am going to finish work early today. Regardless, I was telling myself I'm going to stop working at 8, and that's it. And yeah, it's like 10:50. I worked additional maybe 2.5 hours. I don't know, this shit happens every day. You know, it happens every day. I don't know. It gotta stop, and I definitely I need to redo this one, but I don't think I have any gana to do it today. So okay, this looks weird. So well, hopefully we can solve this one fast, and I can eat. I haven't even eaten yet. Man, my schedule is all over the place. Max number of distinct elements after operations. You're given nums and k. You are allowed to perform the following operation on each element of the array at most once. You're allowed to perform the following operation on each element at most once. Add an integer in this range. Return the max possible number of distinct elements in nums after performing the operation. So we need to have distinct. We can add or minus this. So in the first one, we have 1, 2, 2, 3, 3, 4. So what we do is we can number on both ends can definitely be unique. Well, we sort it first. Okay. After we sort it, on each element at most once. So we can add this much or minus this much. And I want them to be unique. So to make them unique after sorting, I think the best we can do is to make this range as large as possible, right? So like here, I will minus 2 to become -1. This I'll plus to become 6, right? So the best we can do is make this one a 0. That's +1. So can we make it? So basically, we need to reduce this. We need to make this one as small. The smallest is larger than this. So we do it, it's a 0. And then we'll do minus. We take a bigger of the two. And yes, we can do that. So this can be 0. Can this be 1? 1, so we minus this. So basically we have the target, like what we want to get and what we can get, 0 to 4, and it's within, so it's a 1. So this is where target is 2, what we can get is 1 to 5, so we can get this. Target is 3, so we can get, so I can get 1 2 3 4 5 6, we can get 6. I think we can try this. Looks to be doable. Actually, it's 18, right? It's for tomorrow, yeah. Wait, hold on. 17. 16, 17, 18, yeah. 18. Yeah, we're missing 17. Difficult questions require me to be like very fresh, you know, very fresh. And this problem is not that easy actually. I think it take a while. Sort nums and make the best we can do is to get as small as possible. That's one way, or we can say like get it as big as possible. Are these two the same? You know what? I think I want to get another example. So 4, 4, 4, 4, right? So I say, okay, this is 3. So this ideal is 4, and our range is 3 to 5. So I can get 4. Ideal is 5, I can get 5. Ideal is 6, but I'm only 3 to 5, so I cannot. So it's just going to be this. So I still ideal is 6, so the next one will still try 6. Okay, it might not be right. This idea might not be right, but let's give it a shot. We will decrease we'll set the first number to be num0 minus k. Then we know the best achievable number for the next value. Then for the next one is nums0 minus k plus 1. Then we check whether nums 1 minus k, whether the ideal value is in the range of nums1 this to nums1 plus k, right? If so, we can take num0 minus k plus 1 and move on to the next one. Otherwise, we cannot make the number unique for the current position. Now, is this greedy solution correct? Not sure. Do we need to do the same thing from large to small? I'm also not sure. But it seems to be, if small to large doesn't work, I don't see how large to small can work. Right, so it doesn't work basically just means we have too many things that are too close together, right? So large to small also doesn't work. But if small to large does not work, I don't see why large to small would work better. So let's just give this a shot. So we'll sort nums start, not begin, nums end, okay? And then the ideal, okay? Ideal is going to be nums0 minus k. And then 4, and we'll have rest is equal to 1, right? For int I equal to y smaller than size I plus plus. So for each one, so int pre current shall equal to pre plus 1, right? Ideal, pre-ideal, current ideal, and now we say if current is larger or equal to nums I minus k and current is smaller or equal to nums I plus k. So this is possible. Then rest plus plus, then pre equal to current. Right, this is the ideal. Otherwise, the pre does not change. We just move on to the next one. So at the end, we'll return rest. Ugh. Okay, 4 milliseconds. What? Let's hope it works. Nope. 6 and 8 is supposed to be 2, but we don't. So we have to go from right to left. Right to left will be 10, right? And then we want 9. And this is also not working. So basically we start at 6, right? Now if we start at 6 and 8, we're saying ideal is giving 4. So the next one is ideal is 5, but the range is 6 to 10. So in this case, I cannot get ideal, but I can get this one. I get the smallest. So, okay, as long as it's so basically we say if current is, as long as it's smaller or equal to this, right? Because if ideal is larger, then it's not going to work. So as long as it's smaller than this, then pre will equal to std, the maximum of current and nums I minus k. Probably have to do some trial and error debugging. Could be. Oh, I guess it's right. So the idea holds. Okay. Tutorial. Greedy. Current larger than previous. Pre equal to current. Yeah, I think it's the same idea. Yeah, num minus k and pre plus 1. Pre plus 1. Oof. Okay, so we're good. Okay, that will be it. I'll see you guys tomorrow. Adios.